Hello, good day everyone. So today we're going to discuss the structural property. But before we go to discuss the structural property, we were going to have a quick recap about the last discussion about isomorphic binary structure and the binary structure. So now, a binary operation on an empty set S is simply a function. You can see in the PowerPoint presentation, there is a binary operation symbol and the set symbol. So the usual notation for the element binary, the quantity of x and y is x binary, the symbol binary of y, binary, and so it is written as x binary y. So the pair S and or set and a binary is called a binary algebraic structure. So you can see in the PowerPoint presentation about the set and the binary symbol. And now let's proceed to the isomorphic binary. So a function f set 1 and to set 2 is called an isomorphism of binary structure set 1 and binary and set 2 binary. If it is bijective, and you can see the symbol, I will show it in the PPT, so you will understand. And the two binary structures, the quantity of set 1 binary and set 2 binary are called isomorphic if there is an isomorphism fs set 1 and 2s. And now let's proceed to the structural property. And what is structural property? To show the binary structure are not isomorphic, we may show that they have different structural properties. A structural property of a binary structure is a property that isomorphic structures shared. So for example, having an identity element in a structural property, whereas name of an element is not. So here's an example. You can show it in the you can see in the PowerPoint presentation. And suppose the quantity of set and binary is a binary structure. An element E of the set is called identity element for binary. For all x set S is element binary x equals to x binary E element equals x. And I can see in the PowerPoint presentation. Next is the theorem or uniqueness of identity elements. So a binary structure is the quantity S binary has a at most identity element. Proof: suppose element and the other element are two identity element of the set.
So let's proceed. Then E equals E binary, E prime equals E prime, where the first equality holds because E prime is an identity element, and the second equation holds because E is an identity element. Let's proceed in theorem. Suppose S and binary has an identity element E for binary if phi S corresponds S prime as an isomorphism of S and binary, but then the phi E as an identity element of. So let us proceed in the useful properties of binary operations, which is structural. So suppose these are the binary structures or the binary symbol. So commutativity G binary H equals H binary G for all GH corresponds S. And then the associativity G binary H binary key equals G binary H binary key for all GH key corresponds to S. So let's proceed to the existence of the identity elements. There exists an element E correspond to S, such that E binary G equals G, binary E equals G for all G corresponds S. And then for the existence of the inverse element, for any G corresponds S, their existence an element H corresponds S such that G binary H equals H binary G equals E, where E is the identity element. For the lowest one is the cancellation. G binary H1 equals G binary H2 implies H1 equals H1, no H2 and H1. And then binary G equals H2, binary G implies that H1 equals H2 for all G, H1, H2 binary corresponds to S.